Okay folks, in this video we're going to start looking at the practical applications of some of the things that you've learned thus far. And what we want to do is give it to you kind of like in question answer form, see how you're doing in your own mind, and let's go through a couple examples to kind of really lay some of this material home. So for example, if we just have a simple part that looks like this on a drawing. The first thing that we can tell right off the bat is that this is a cylinder because that we see the center line. Now the next question may be, well, does this cylinder go all the way through the part, or is it sitting on top? Well, the answer to that is that it has to be on top because the center line stops right there. It doesn't go, if it went all the way through the part, the center line should come out through the part. Plus, there would have to be some hidden lines that would show up at that point as well. So those are a couple of things in decision-making processes that we use to make some determinations of what we're looking at on a drawing. Now, of course, the drawing would also include let's say this is the front view, so a right side view of the part as well is what I could determine from it. Now, I could probably get by with only two drawings and no top view because we know that, of course, this is a cylinder. But most likely the designer would include it nonetheless. But then let's turn around and do something like this. Let's go ahead and say that in addition to this, we see, whoops, supposed to be using the paint tool here. Yeah, the marker. That's too big. Hold on. Here we go. I don't like the painting. Let's go back to the pencil. Works. There we go. In addition to our drawing, we have this little feature. And let's just say we see the following things. Flag here, circle there, symbol there, let's say something like this here, and let's say that's all we see. In fact, we'll say TYP. So we can move this over just a hair. Okay. Now, let's break it down. We look at the welding symbol. All of this is the welding symbol. We look at this to determine size. We look at this to determine what type of weld. We see this, which tells us that it is in fact going to be done in the field, and this tells us it's going to be an all-around weld. Now, a couple things that I don't have on here. Of course, this also tells us that this is a typical application for perhaps this part or something else on the drawing. Now, since I've only got one part here, the word typical probably doesn't make much sense. So let's just go ahead and say that it doesn't have that, because this would be something that you would see on a set of drawings for maybe some large-scale fabrication and a lot of stuff. Typically, what we're going to see is nothing on the tail if there's no extra information. Or, let's say there is a tail and it says GMAW, a process. So we break it down into those features and it tells a lot of stuff. The key thing with complex drawings is to try not to get overwhelmed, but look at one particular item at a time, because that's all you can deal with at once anyway. Okay, let's say we have a joint that looks like this. Let's say we've got two pipe cylinders that have been pre-beveled. And we'll just go ahead and put a brake line in right here, and a brake line in right here. Move it down just a hair. And let's say we add in a welding symbol. Looks something like, I don't know why I'd automatically do a tail. It's supposed to be in there touching that edge. I didn't do a very good job of that. And let's say that we see this. Well, first of all, that makes sense because we're dealing with a part that is probably got a center line through it. So seeing the all-around symbol makes total sense. But let's say what kind of weld would probably go in here? Probably not a fillet weld, obviously, but a V-groove would be just fine. Now in this case, there's no angles included, because if there were, it would have to be implied right down there. And there's no extra information about some kind of contour, which would also be down in this case. But let's say that this part is part of an assembly drawing, which has multiple parts put together. So for example, this is part A, and this is butted up next to part B, and therefore this is an assembly drawing, and therefore it might be common to see TYP on the end to say, hey, every time you got this type of situation, do this type of weld. Now, right off the bat, you're not seeing a size, which is implied given the fact that you've just got this weld, got this gap, you're going to fill it in. Well, let's try another one. What if, while we're on the topic of pipes, let's just say we have a pipe here, and I'm going to try the ever difficult ending termination. There we go, that's not too bad. And let's say we're dealing with two parts once again that are butted up next to each other. Now, again, for an assembly drawing, it has to have more than one part. In this case, what we're looking at are two separate parts, part B and part C on the assembly drawing. And obviously, if you remember, this tells us that this pipe and this pipe and this pipe are actually just broken so we can see the cross section of them. And since we don't see any walls, this actually is some kind of solid shaft. Now let's just go ahead and make some assumptions. Let's say we run into a weld that looks like this. And then we throw a symbol up on top of this, maybe a little something here, and let's say that we add in a number here. So what are we dealing with? Well, first of all, I didn't put an arrow in. There we go. We know it's going to be a factory shop weld because it's going to be, you see no flag. You also notice that we don't see a all-around symbol. Well, what does that mean? That's a round pipe, so the all-around symbol is kind of implied with a groove weld given this particular situation. Now, what's actually physically occurring? A couple things. First of all, you got a V-groove weld, but you're actually applying some backing, correct? And the backing has a classification. What kind of classification is the insert for it? A classification 4, and which results in kind of a V type of insert. So this detail basically breaks down the fact that we're going to do some V-grooves. We do have a contour symbol right there, which implies that we need to do what kind of contour? Well, we want to weld that when it's done. If this is the V-groove weld, we want it flat across the top. We don't want it to bubble up or down or anything like that. So there's a breakdown of kind of what that one looks like in reality. Now to mix it up a little bit, what if someone were to turn around and say, or to do things a little bit different, where they were to make some extra notes here. For example, let's say that they wrote in, I'll just leave it as it is, and they were to say grind flat. Well, if they were to write this past the tail as a specification, then they would probably not bother with this detail or this contour symbol because they're actually writing it out. Or they may, you never know. So this kind of information may be at the tail, may be shown there, maybe doubled up. It's hard to say. But that's a good start process with it. All right. Now let's look at a structural drawing. Let's say that we're going to take a W-beam. By the way, in case, just for terminology's sake, this, if you're doing structural steel for buildings, is a W-beam, not an I-beam. An I-beam and a W-beam are actually very different shapes. Well, the I-beam just doesn't have a wide flange, whereas this shape has a nice wide flange. That's what it stands for. The W is wide flange. So don't get to calling them I-beams. They are not I-beams. They have an I shape, but it's more like a turned sideways H than anything else because of the wider flange. Anyway, a lot of common things happen in steel fabrication. Let's start off with some basics. Let's say that a person has to come in and attach a piece of angle. And we were, of course, looking at a cross-section situation. They have attached a piece of angle and they have to attach some kind of plate to it. All right? They're going to do some welding in this scenario. Most common weld that's probably going to happen in a fabrication process is, especially in structural steel, is going to be a fillet weld. So you might see something like this. An arrow right here, the fillet weld symbol, implying that it's on the arrow side. But almost all this kind of stuff is going to be field welded because it's done actually in the field. And they have to weld that piece, and then they're going to turn them around and weld this piece as well, potentially in the field. So you would see the same size weld, and they would put the size in here. Let's say it's 3/8. And it may not be something that's done, it depends on how long this overall system is, but let's say it could be 3 by, we'll say 15, meaning that it's a 3-inch weld every 15 units. But you're going to notice something of interest in this particular case. Right now, what I'm telling you to do is to weld right here and to weld right here. But what if I want you to weld some other places? What if I want you to weld right here and also right here? I would have to turn around and then add this to the top. Now, do I have to duplicate all the information? Maybe they will, maybe they won't. Kind of depends. A proper procedure would be to duplicate all this information up on the top as well. But in this particular case, we're going to just say they leave it blank. Still okay for you to figure this out. Especially in structural fabrication, you don't always have the same conventions and designers as you do more in mechanical applications. Now, let's say there's some other processes that go with this. Let's say that this particular steel beam is sitting on a steel column, and we're going to need to do some welding between this edge and this edge. Well, one of the most common, actually let's change it up a little bit. Let's say that this thing is going to be sitting on a steel plate, which is, it's very common to actually take a steel column and cap it. And then that's what runs into your steel beam. So whereas this might be a fillet weld all around, arrow side, this, of course, may or may not be a fillet weld. It kind of depends on the process. You know, where the actual column starts or ends, or I'm sorry, the beam starts or ends may be an edge weld. You never know. Let's see what we can do. Well, let's say if these two edges actually are flush with each other, we might be able to get away with an edge weld. So this could be something along the lines of this. Or somehow we might be able to do a groove weld in the same case too. So if we could do, let's say, a square groove weld. Now, would we be able to go all the way around with that? Probably not, because we'll assume that the steel beam goes into the page more and we would maybe get around it. But there's a lot of variations that could happen in this particular case. Now, one of the things that you'll commonly see on steel fabrication drawings is they'll get away from doing a lot of sizes. They'll probably have a note somewhere that says, see specifications or specification packet, so they can write how the welds need to go, and they'll just show the symbols in kind of these vague forms on the plans, and you're supposed to go read the specs as to what size, length, pitches, those kind of things that need to be provided. They like to keep the amount of high detail stuff onto specifications and keep the drawings as, you know, semi-vague as they can, it seems sometimes. Now let's just say, for example, that this particular component also has some steel decking across the top of it. And that cross section will look something like this. It can be shown in a lot of different ways. Actually, steel decking in this case would probably be running this way, with a thin edge of it. By the way, steel decking has a cross section that looks like this, in case you're wondering. Anyway, how are we going to attach this? Well, we're probably going to have to do some type of weld right here. What would you think that is? Probably a plug weld. So we're going to need to, technically the joint is right here. We're going to need to show the plug weld. Now, here's a good question. Would this be arrow side, or would it be other side? And technically the joint is right here, so it's the arrow side, but technically the weld starts up here. So you're probably going to see them call it arrow side in this particular case, and they're probably going to give the diameter of the plug weld that they're going to use right there. Now, plugs are going to definitely have some size. They may actually, if they're slots, they may have a length and pitch associated with them, but it's something that you could see. Now, plug welds can very commonly be done in a note form, where they'll just have a specification that says when you have some metal decking going across a W-beam or some type of steel joist, you are to weld such and such and such. So that would be handled in some form of a written specification. All right, that's a good trial run. Let's go ahead and pause or stop the video now, and we'll catch you on the next one.